Okay. Good morning, good afternoon, and good evening, everyone. My name is Vanessa Panettieri. I'm a senior medical physicist at Peter MacCallum Cancer Centre in Australia, and also associate professor at University of Melbourne and Monash University. And it is my great pleasure and privilege to have here today and interview Professor Tomas Kron for the Asia-Oceania Federation of Organization for Medical Physics, as we call it, the AFOMP. So today we are doing this interview for the Meet the Experts series, which is a series that aims at celebrating the contributions of the most influential medical physicists in our region. So thank you very much, Thomas, for making time to meet with me and for also going through this interview with me. So thank you very much.
Thank you. I'm really delighted and very much honored to be part of this series.
And we are very, very privileged to have you here. So before we start, I'm just going to read a little bit of a bio. I have a presentation for you all. And so, as I said, today we are very lucky because we have Professor Tomas Kron. And Professor Tomas Kron was born and educated in Germany. And after his PhD, migrated to Australia in 1989, where he commenced his career in radiotherapy physics. And Thomas was very, very generous. He gave me some of the pictures that he thought would be interesting for you. One of these pictures is here. And it's him with some phantoms that he was very fortunate to be able to buy with a grant that he won in 1990. So from 2001 to 2005, Thomas moved to Canada, where he worked at the London Regional Cancer Centre on the commissioning of the first tomotherapy units. And I think this picture is from Canada, but it's a little bit later in 2007. And in 2005, Thomas became principal research physicist at Peter MacCallum Cancer Centre, where we are here today in Australia, where he's now our director of physical sciences. And he holds academic appointments at Wollongong, RMIT, and Melbourne University. So here, just to show you the old Peter Mac building, and this is one of the IROC Phantom that came to visit us in 2010. Thomas is very inspirational for us. He's been mentor to a lot of us and has an interest in education of medical physicists, dosimetry of ionizing radiation, image guidance, and also clinical trials. In fact, he's very active in TROG. And this has been demonstrated by more than 350 papers, which are in refereed journals, and more than 100 invited conference presentations. So it's a privilege to have you here. And as you know, most of you know also, he's author of some of the books that we find on our shelves in radiation therapy. And also he has written a chapter in these True Tales of Medical Physics, which I've been reading in the past few days, and it's really interesting to see the experience of other physicists in the field. Also, I think Thomas has an interest also in writing other types of literature, and he can tell us more about it. So thank you very much for joining us. And maybe you can read the motto on the T-shirt, because I don't think my German is up to scratch.
Delighted. I'm really privileged to have an opportunity here to have a bit of a chat with a lot of colleagues, hopefully online, and share some of the experiences and really some of the luck I had throughout my career where I am now. Very much the motto on the T-shirt says, "Schauen wir mal, dann sehen wir schon." And that was the motto of the trainer of the German soccer team, which basically says, let's see and we will see. So lots of wisdom in all that. I might get started to go sort of back because Vanessa has sort of shown you one of the children's books I've drawn. And I was always really interested in trying to get messages across in a variety of different ways as such. And these comics were certainly a nice way of getting things off my chest and trying to put complicated or interesting things forward in a way that makes it easily digestible. I could talk about cycling and kings for a long time, but I think that's probably not what we are here to hear about. So I'm interested to hear what questions you may have.
Yes, well, we are interested in your experience. And so um, maybe you can talk to us a little bit about yourself and tell us how you ended up joining the field of medical physics and chose to become a medical physicist. We're very interested in that.
That,
Thank you.
that's a really interesting question, and I do not just wear round glasses, but the medical physics start is probably a bit like Harry Potter and the wand, because it's not the wizard choosing the wand, but it's really medical physics which chose me. I would say I studied philosophy. That was my first primary subject, and the philosophy sort of led me after a year and a half into something more tangible, something a bit more challenging in a rather different way, where philosophy really teaches you what questions to ask, and physics sort of teaches you what what premises you need to put, what assumptions you need to have in order to make questions which are answerable. So it's a very different approach, and obviously being young and impressionable, the idea of actually answering questions was very attractive. So I did solid state physics and then a bit of biophysics, and then moved to Australia with my wife, or then my partner. We got married here, and I needed to find a job. So I looked for all sorts of jobs, and one of them was a medical physicist, and I had absolutely no idea what a medical physicist is. I was very fortunate to get that position. In hindsight, it was in radiotherapy physics, and I was also very fortunate that my most important teacher was probably a radiation therapist, and he took me under his wings and showed me the radiation therapy from a practitioner's perspective, from someone who actually treats patients. And that is certainly something which is still with me. I was taking over the in vivo dosimetry program then, which allowed me to basically daily go and see patients, put TLDs on their skin, introduce myself to them as a physicist, and try to explain why a physicist was actually there. Patients were always very generous in their time and allowing physicists to be part of their clinical team. And that's probably something which is still a very important influence on to me.
Yes, that's certainly something that we physicists have to keep that contact with the patient. And if you think about your early experience, can you tell us about it, how it was in the early days of your career, and if there were any highlights, any challenges?
I I think most of it were really highlights. It's sort of a bit like Alice in Wonderland, as a academic physicist with a PhD, and I could tell my logs from the exponentials, but I really had no great idea about how to was that relevant, and being in a clinic really very quickly sort of showed the problem that we needed to somehow make what we've learned, the physics, all that, relevant to patients, and at the same time trying to explain that relevance to our colleagues from radiation therapy, from dosimetry, from radiation oncology, and the clinicians. So the first highlights were really trying to find these explanations. And if these explanations then also held when I was at a party and trying to explain to people who sort of looked blank when I told them I'm a medical physicist, ha, 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 ha. And they were saying, oh, if I emphasized physics too much, they would start yawning and looking for someone else. If I emphasized medical too much, they would say, "Oh, it hurts here, and can you do something about it?" But trying to find simple explanations of what we are doing and what we can contribute was probably both the main challenge and the main highlight of these early days.
Yes, and you were telling us the other day that you had the luck to work with one of the first tomotherapy units. It must have been exciting to be like, at the forefront of some of this technology. Can you tell us a little bit about it?
Yes, I always sort of tried to maintain some interest in research and not just trying to, as we just sort of discussed, translate what physics does and see how that can help patients, but also trying to develop or follow what happens in physics and at the same time trying to make that still applicable to patients. And when Jake van Dyke asked me at the time, sort of around 2000, if I was interested or would be considering helping with commissioning of the new type of equipment, tomotherapy, helical tomotherapy, I was obviously completely excited. At the time, I was chief physicist in Newcastle, and really administration became at the forefront. It was quite clear hospitals pay me for administration, and I wasn't ready at the time for any of that. So I did talk my wife Robin into going to Canada for 4 years. And I joined an absolutely fantastic team there and spent about 3 years, trials and tribulations, getting something which did deliver the most gorgeous dose distributions. Unfortunately, only on 3 or 4 days a week. On the fifth, it was down. Something was broken, as you would expect with new equipment. And for me, the realization then that the continuity of patient treatment and reliability are really, really important was obviously very important. The other aspect was that everyone looking at these gorgeous dose distributions, because IMRT was something we just had sort of discovered, the clinicians were clearly concerned, saying, this is so good, everyone will want it. But no one actually knew exactly what it was best for or who could really benefit from this. So I got introduced to that idea that introducing new technology through a clinical trial is actually a great way of going forward. And that's basically what we did. We set up a clinical trial, prospectively asking questions, prospectively defining what the criteria were to say, yes, this is successful, and at the same time selecting the patients in a way that we can maximize our learning from that. So it was a very, very exciting experience to work there with colleagues in London, Ontario, and also learn ice skating. But that's a different story.
And is that one of the challenges of
The
your early
ice,
days?
the ice skating, probably the challenge is to cope with the idea that the young ones, and my son in particular, in this case, Edmund, skated so much better than I did. And they were really running rings around me. So it's a bit of a challenge as such, but it is also really great fun and helps to bring people together.
Yes. Now it sounds like a very good experience. So if you think about motivation in your career, what are, the aspects that have kept you motivated and dedicated during these years of the profession?
I think probably the most important thing is colleagues. I always was sort of surprised wherever I went and working with really a vast variety of people. And it's not just medical physicists, it's RTs, it's dosimetrists, it's oncologists, it's nuclear medicine physicians, radiologists. Everyone in this sort of an environment was in one way or another inspiring. And that certainly helps someone to maintain this interest and sort of that see that people were not just inspiring, they were also different. They were, and that's probably more so for the medical physicists, where there's such a variety of medical physicists that it's really never boring, not even by communicating with people with a variety of skills. So I think it's really mostly the people one can work with as a medical physicist, both professionally, but also the patients, patient advocates, clinical trials people who really make the difference and make it actually really a joy every morning to come to work, and expecting that something has gone wrong, expecting that it will not be the same as yesterday. And that expectation was virtually always met.
Yes, and I think it is every day different for us in the field, in the profession. So if you look at your career, what are the accomplishments you're most proud of? The ones that are giving you ultimate satisfaction and happiness. It's almost a philosophy question here.
I think that's a good question, and there are probably a couple of things I'm sort of proud of. One is throughout my career, I've been involved with about 20 PhD students, and I think that is really an absolute privilege. As one sort of grows older, and one sort of realizes that the fresh ideas are not just coming as quickly anymore. They may not come at all as such, but working with younger colleagues who still have that urge and that idea that they want to make the world a better place is really wonderful. And to work with PhD students in particular who have that drive to want to change the world, make something really outstanding, become the expert in something or other. And your real main role is really to say, now stop, right up, stop. This is enough. This is enough. Let's not. You can continue doing research. You can continue doing good work after having handed in your PhD thesis. You just get better paid, hopefully. So that was really one of the great privileges. I'm also proud that I was part of a group of people who started with clinical trial audits, now resulting in a requirement in Australia nationally that all radiotherapy units are audited and are checked by ACDS, the Australian Clinical Dosimetry Service. And I remember, so sorry to digress here, but I do remember that we had long discussions about the name of ACDS, because it was first ACDC, the Australian Clinical Dosimetry Centre.
Yeah, I can see how that could have been confusing.
It was not only confusing, it was also probably a copyright infringement. But some of the more politically minded and people sort of thought that was probably not the right message we wanted to get across. But it's good to see that the ACDS is still out there doing really great stuff.
Yes, and definitely making us in the clinic feel more, safe about what we are doing every day. So if you think about the current developments in medical physics, how do you see the future of our profession?
Oh, that's an interesting question, and you shouldn't ask someone older than 60 to talk about the future as such. So, from my perspective, the future will be patient-centric. Medical physicists are always the sort of interface between technology and the patient. And the technology is developing, and we are participating in the introduction of machine learning, of fantastic imaging tools, and so on. And we still need to make sure that this link to the patient is there. And I think being on the patient side and understanding the patient's needs will really guide us not only to translate technology to the patient, but also help guide the development of technology in a way that patients really can maximize this maximum benefit. That, however, sort of means that I think we will probably lose that specialization as a radiotherapy physicist or as an imaging physicist or a nuclear medicine physicist. I'm sort of always dreaming of, let's say, a lung cancer physicist who would basically be there looking at the lung cancer screening program, low doses, fast turnaround, then at staging, at all the different imaging modalities thrown at that patient, looking at the motion management, looking at trying to condense the treatment from 8 weeks to 1 week, 2 weeks, to then potentially even following up and trying to link particularly clinical outcomes, be it toxicities or cure, to what we've done. That's sort of something where I think we can all benefit from a physicist who's accompanying the patient through their whole journey and adding value really in all these different steps. So I'd see us becoming much more broad in our approach. This obviously means there's a lot of learning to be done, but that's something we have learned to learn as part
Yes,
of our professional career.
yeah, I think it's what we like to do anyway as medical physicists in the profession. And I think the vision of us as full part of the multidisciplinary team, it's a very nice vision and a very, exciting sort of perspective. And we've heard about your life philosophy, or at least we've heard about your life motto. But we like to finish this interview with a little bit of a message to the early career medical physicists that are starting in the profession. Do you have a message for them?
Maybe the message is sort of my grandmother's message. She wasn't a philosopher, she wasn't a physicist. She was a hardworking woman who really worked through 2 wars and all sorts of disasters as such. And her motto was really, I can work and I enjoy it. She said that in German, but that's sort of the gist overall. And a bit later in my career, I learned of someone who said the same thing, but much more eloquently as such. Rabindranath Tagore is an Indian author, philosopher, Nobel Prize winner, and he sort of reworded that in a way which I always found really, really inspiring. He said, I slept and dreamt that life was joy. And obviously we all want joy. I awoke and I saw that life was service. I acted and behold, service was joy. And I really like that, the idea that if we can contribute something, and we might as well enjoy it, or we probably will actually enjoy it. And that is something which sort of takes me back to my grandma, who I was very close to. And I certainly, for me, that rings true, even if 50 years ago, when she first told me that, I thought, oh, I'd much rather lie on the beach. But I think maybe studying physics or growing old sort of changes life perspective.
Thank you very much, Thomas. I think this is a very important message for everyone. And if we probably do a survey of medical physicists, we will see that, a big number of us enjoy the profession. So I think this is a good perspective for the early career physicists coming into this field. So thank you very much. I don't know if you have anything you want to tell us in addition. Otherwise, thank you very much.
I think just to say thank you so much. And for those who are still online, thank you even more. And I really feel very privileged and happy that I had this opportunity. Thanks.
Thank you very much for joining us, Thomas. Bye, everyone.